All right, today we're diving into a piece of Web3 infrastructure that some people are calling the Google of blockchains. It's called the Graph, and its whole mission is to organize all the world's decentralized data. So to really get this, let's start with an analogy. Picture a giant global library that has every single thing ever written on a blockchain. Now, imagine there's no catalog, no index, no search bar, nothing. If you wanted to find just one specific piece of information, you'd literally have to sift through every single book by hand. That, in a nutshell, is the massive problem the Graph was created to solve. And here's the crazy part. This chaos isn't a bug, it's a feature. You see, blockchains were built from the ground up for one thing: security and decentralization, making sure every transaction is locked in and can't be changed. But they were never, ever designed to make it easy to actually read all that data back out. This is kind of like the original sin of blockchain design, and it's a huge headache for anyone trying to build a decent app.
So before the Graph came along, if you were a developer, you were pretty much stuck with two terrible choices. Option one, you could build your very own centralized server just to index the data. This costs a fortune, takes months of work, and, worst of all, it completely defeats the purpose of decentralization. You end up with a single point of failure. The other option? Just try to ask the blockchain nodes directly. And trust me, for anything more complicated than a basic wallet, this is so painfully slow it creates an absolutely awful user experience.
So the big question is, right? How do you fix this mess without giving up on decentralization? Well, the answer is you build a decentralized solution. So let's look at how the Graph did, by basically creating a global network of librarians to finally catalog the blockchain.
The secret sauce here is something called a subgraph. The easiest way to think about it is like a custom-made digital card catalog for a very specific set of data. Developers can build these things to say, hey, this is the exact data I need, and this is how I want it organized. And just like that, you've created a bustling open marketplace for data.
And for the developers? Oh, this is a total game changer. Remember that months-long process of building your own server? Yeah, that gets cut down to weeks. Those insane infrastructure costs? We're talking savings of up to 98%. And that single point of failure problem? Poof, gone. Replaced by a super resilient global network with incredible uptime.
But okay, a global, decentralized network can't just run on good intentions, right? It needs fuel. And this is where it gets really fascinating. The Graph didn't just build a tool, they built an entire self-sustaining economy, all powered by their token, GRT, to make sure the whole system works.
So let's meet the players. First up, you've got the indexers. These are our librarians. They're the workhorses of the network, running the nodes and doing all the heavy lifting. They have to stake GRT tokens, kind of like a security deposit to show they mean business. And for all their hard work serving up data, they earn fees and rewards. But wait a second. With thousands of these subgraphs popping up, how would an indexer even know which ones are worth their time? Ah, great question. That's where the curators come in. Think of them as the network's data critics or tastemakers. They use their GRT to signal which subgraphs are high quality and valuable. It's a really clever way to point all the indexing power where it's needed most. Okay, next up, delegators. These are basically the investors of the ecosystem. So let's say you've got some GRT, but you're not about to go run a complex server yourself. No problem. You can delegate your stake to an indexer you think is doing a great job. By doing that, you help secure the whole network. You boost the indexer's earning potential, and you get a cut of the rewards. It's a win-win. And that brings us to the final and maybe most important piece of the puzzle, the consumers. These are the customers, the dApps and developers who are actually using all this beautifully organized data. They pay small query fees in GRT to get the info they need, and that demand is what makes this entire economic engine spin. The whole system is kept in check by a really neat token design. On one hand, you have a small amount of new token issuance each year, about 3%, to reward the indexers. But to balance that out, the protocol actually burns a portion of the fees from all network activity. So the more people use the Graph, the more tokens get burned. It creates this fantastic deflationary pressure that's tied directly to adoption. Okay, so the theory sounds amazing, but how is this all playing out in the real world? Let's check the scoreboard, see how the Graph is actually performing, and take a look at who they're up against in this race to become the go-to data layer. Whoa, just look at this number, 369%. That's the year-over-year growth in the actual fees that apps are paying to indexers.
This tells you everything you need to know. This isn't just a cool idea anymore. Real projects are paying real money to use this decentralized network. That right there is what product market fit looks like.
And we're not talking about small-time apps either. Who's actually using the graph? Oh, just the absolute blue chips of Web3. We're talking Uniswap, Aave, Decentraland. I mean, the biggest names in the space. They all rely on the graph. It's not just a nice-to-have tool anymore. It's become the foundational plumbing for so much of DeFi.
Now, you might hear some people look at the numbers and say, hey, the protocol's revenue seems kind of low for its valuation. And look, that's a fair point if you're only looking at today's cash flow. But that's missing the forest for the trees. The graph is playing the long game. This is an infrastructure play. The real value is how deeply embedded it is. Once a giant like Uniswap builds its entire application on your rails, the cost and the headache of switching to anything else becomes astronomical.
Of course, they're not the only ones on the field. You've got rivals like Subsquid and Subquery that are incredibly fast, and others like Covalent that have a totally different no-code approach. But here's the kicker, and it goes back to their whole philosophy. The graph is fully decentralized right now, today. And in this space, that is a massive, massive advantage.
So, where does it go from here? Well, the roadmap is incredibly ambitious. The plan is to evolve from being a must-have tool for crypto developers into becoming truly invisible infrastructure that powers the entire future digital economy.
There are 3 huge things to watch. First is Substreams, a massive performance upgrade for real-time data. Then you have Hypergraph, which is all about privacy-preserving queries. This could open the door for huge enterprise adoption. And maybe the coolest of all is the Graph Assistant, an AI-powered tool that would let literally anyone query blockchain data just by asking questions in plain English. No code required.
And this quote really just nails their ultimate vision. The goal isn't for everyone to know what the graph is. The real sign of success is for it to become so fundamental, so reliable, that it just disappears into the background. Just like you don't think about TCP/IP when you're browsing the internet. It just works. That's the holy grail, to become invisible.
And that leaves us with one big thought-provoking question. Sure, some competitors might be a little faster today, or have a specific feature that's better. But if the graph actually achieves this grand vision, if it becomes the default invisible data layer that everything is built on, then how on earth do you compete with infrastructure you can't even see?